Graphing fails. And what's going to happen is graphing to get the answer is only going to kind of work. It's a problem. So here's what I want you to do. On your sheet, a review from yesterday. I've given you two graphs there, and I graphed them for you. They're already graphed. We're not going to get caught up in how to graph just yet. Your job is to, on your piece of paper, put a dot where you see the, I won't even say where it is. I won't point at it. Put a dot where you see the point of intersection. Take a moment to do that. Then write down what that point of intersection was. And something's going to go, well, it's not something that goes wrong here, but there's a problem. There's a problem. So take a second and try both those things, please. Put a dot at the point of intersection. Hopefully you know what that is. And then write its coordinates. And get ready for the problem. If it's a little bit of a problem, well, just got it. You're going to wonder about something. You're like, well, yeah, okay. Take a moment. I'll do it slowly. So if you're really stuck, you can look up at me and write what I write. After you've got the point of intersection, just look over at a friend's answer and see what they wrote for both of those. Do both of them. It's an important point I'm going to make here. A little joke there. Important point. Excuse me. Okay, let's get someone to share their point of intersection. There are many potential right answers here. You might have got slightly different answers. There are some answers that would be wrong. But is someone willing to share their point of intersection for the first one? What did you say for the answer? Say again, was it? 1 point. And what did you decide? 1 point. 1.3, yep. I like it. And 2.2. Most of it is fine. There is a little problem with his y value. Negative. It's got to be negative. Okay? But is that what you wrote down? Did you write down something slightly different?
Yeah, I wrote something.
What did you get?
I got like 1.5.
Like 1.5. And you might even look at it and go, well, how am I supposed to know? It's somewhere between 1 and 2. But someone else might write 1.3, someone might write 1.5. What about negative 2.2? Did anyone get something different than negative 2.2?
I got 2.2.
You got 2.2 as well, so you thought the same thing.
I got negative 2.1.
Negative 2.1. Do you see the problem? And graphing has this problem. There is no way in the world people are just using graphing to solve problems. Because you're not sure if it's the right answer. Well, you got an idea. It's pretty close, but you're not sure. How about this one? Someone want to share what they thought? I really tried to exaggerate this one. What did you get for the x value for this one? 4.1. I like it. I don't necessarily love it. You know, like someone else might have gone, oh no, it looks like 4.2 to me. Looks like 4.3 to me. Yeah, okay. What about the y value? This one was 120. 122, maybe 123, maybe 122.5. This is why, and it's an exaggeration. The title says graphing fails. Well, it didn't fail, but it only can give you an approximation, sometimes. Yesterday, I made them all work out. You're thinking back to yesterday and going, this wasn't a problem yesterday. I rigged them all up. I made them all work out beautifully. They generally in life, things don't work out beautifully. Okay? So what did I say in the note here? Let's take a look. When done, compare your answer to the friend. Were your answers the same? Not always. And it wasn't because people were wrong. That's not what the problem was. The problem is, with graphing, you can't get the same answer. You might not get the same answer. You get a close answer. That's the best you can do is close. Comment on how accurate you think the graphing method is. I'm going to say not bad, but not great. You can't tell me the people that are building iPhones and making GPS systems and sending people into outer space, they're not getting approximate answers. They've got a way to get the actual answer, the actual decimal answer. What causes the inaccuracy in the graphing method? Gaps in the scale. Well, actually, there's all sorts of things I could have wrote there. But the gaps in the scale were the problem. There's a gap between 2 and 3. There's a gap between 120 and 125. So those gaps in the scale made it so graphing couldn't get a perfectly accurate answer. That's what I'm up to today. Can we do this without graphing? In fact, a couple people yesterday said, almost with disdain, they didn't like graphing. They wanted something different than graphing, because they want to have to go through the graph every time to get these answers. That's what I'm going to show you to do. How can we do it without graphing and, in the process, get very accurate answers? But it's not simple. It's not simple. Yeah? Flip your brain on. All your attention right here. I designed this lesson very carefully, step by step, so you can't skip any steps. Got to stick right with me all the way through. Substitution saves the day. Try graphing to find the solution. So I am going to go back and do one with graphing first. And then I'm going to do the exact same question without graphing it and try to convince you there's another way that doesn't involve graphing. Okay. One at a time. Y equals x plus 3. Let's just talk about that line for a second. Because graphing that line actually was a bit of a problem on the test for some people. Not as many as I expected. It was really good. I was really happy with how people handled it. Some people asked me during the test, like, do I just do this? And I was like, yeah, it's beautiful. Well, let's just deal with the y-intercept first. What's the y-intercept? 3. That went really well. Let me label that again. That's the y-intercept. Most people nailed that. But what's the slope? Slope is 1. Yeah. He said 1x, and you know what? Saying 1x is not necessarily incorrect, but it gives you more information than you need. 1. Well, look at that. I cheated. I totally gave away what I got to do next. Look what I did there. Look how I wrote the 1. So silly. I tried to give a hint there. Thinking of it as 1 isn't going to help completely. When I get a whole number like that, what do you picture it over? 1 over 1. That's the best way to think of what that slope is. So now when I go to graph it, here I go. Over 1, up 1. 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 There we go. Now I must tell you, I very carefully on the test did not put the other line, these type of special lines on the test. They're very weird and special. We did study them, but I didn't want them to be on your test and cause you a problem. The other line is called x equals 6. Completely different. What it says is, and you got to look, you got to watch me do this to understand. It says if you want the line x equals 6, x has always got to be 6. That's what x equals 6 says. No matter what you do, x has got to be 6. So let's talk about some points where x equals 6. This has x value 6. This point has x value 6. This point has x value 6. So that's a special kind of line. We did study it in one of the sections last chapter. We talked about what x equals 6 looks like. And it's a vertical line. It goes straight up and down at x equals 6. It's so ridiculously easy that it becomes hard. We've been doing these really hard y equals mx plus b lines, and this one is just x equals 6. There it is. Try graphing to find the solution. I did it. The solution is right there. Can you see it? What's the coordinates of that thing? 6, comma? 9. Okay, a good question right now would be, Mr. Todd, that one worked pretty well. Why are you using that one to find a new method? It's an old math teacher trick. Not because I'm old, but because for thousands of years, math teachers have used this trick. Do an example we know how to do. Do it another way to make sure my new way works. So I'm going to do the exact same question without all the graphing. So if you haven't enjoyed graphing so far, you should try to love what I'm going to do next. I'm going to try and do the exact same question without graphing anything. You are going to put your phones away while I teach this example. And that's on the video now. Now, wouldn't that be cool if your parents watch the video now? Like, did you have your phone on, Mr. Todd's class? That's what you get. Question. Not yet. My big moment's coming here. Do you need more time here? Here's me doing the question with no graphing. Exact same answer with no graphing. Get ready. What if you had no graph paper? Look at the two equations. What is the answer? I say I can figure it out just by looking at it. What does the x value have to be in the point of intersection? Big, big moment.
6.
It's got to be 6. Look at it. The second equation literally tells you x equals 6. That makes this one easy. I chose one that could be handled this way. So x equals 6. Now, not by looking back at the graph, but just by looking at the equations, if I know x equals 6, how can I get the y value? Hold on, say it again. Look at the variable. Now I've got the x. Once I've got the x, and you should write this in. This is one of the most important things I'm going to do today. Draw this arrow going, oh, now I know that x is 6. I can get the y value. Y equals 6 plus 3. And what's 6 plus 3? 9. All I did was look at the algebra of the situation and figure out what the x and y have to be for these two lines. I said, okay, I know the x is 6. The second equation tells me that. To get the y value, I take that x value of 6, put it into the equation, and I get the y value. Question?
Like the brackets, the 2 points, the second one, which was the y, is in that. Could you just do that, though? Or not for all?
Not necessarily for all of them. Yeah, wait for me to do some other examples. This one's set up to do it. So I can find the answer by substituting one equation into the other. This method is called solving by substitution. You're just putting the equations together. So let's look ahead for a second. Here's what I'm going to do. I'm just going to use that method. I'm not going to graph. I'm not going to graph. I'm not going to graph. I'm just going to use that method to keep subbing in to find answers. They'll get progressively harder. Let's start with some pretty straightforward ones. Y equals 2, x equals y plus 1. I'm going to write the answer over here. Somebody tell me. By just looking at those, the way I've set it up, you can look at it and know either the x or the y. You already know one of the answers. Which one do you already know? It literally says y equals 2. You're like, what's the x and y? The first equation goes, well, just look. I got it right here. Y equals 2. I'm just going to write that over here. Now, if you didn't understand the first one, pay attention now and watch this, and somebody will try and explain it. How am I going to get the x value now that I know the y value? Right. So draw this arrow. It's going to help you understand. Draw this arrow and go, oh, y equals 2. I can put that right in there. I can substitute it in. This is why in the first couple of weeks of this course, I was like, let's do a bunch of substituting, because I knew we had to do this at some point. So x equals 2 plus 1. And what's 2 plus 1? 3. Now I've got the point of intersection. If somebody graphed those two lines, they'd find out they meet at 3, 2. Now, if you think that's easy, you're like, why are you making such a big deal about this? That seems pretty straightforward. There's an example coming. This third example, also an easy one. And then things are going to get crazy. Get ready. Reach down and get the seatbelt off your chair and do up the seatbelt and go, oh boy, here we go. Things are about to get crazy. Okay, yeah, let's try this one. We want to know the x and the y. I'm going to put it over here. What x and y are we trying to find? Well, look at the equations. Is one of them right there? Is one of them just handed to you on a silver platter? Yes. Which one? X value 4. Now, what do I do with that 4?
2 bracket 4 bracket.
He says sub it in. Let me write a little more. The other one, I just wrote the arrow, okay? To just get the idea. Let me just write a little more.
So when you do
Sub
2 or y equals 2 bracket 4 bracket.
sub x equals 4 into y equals 2x minus 5. Yes, I'm just trying to catch up with what you're saying, Joseph. So y equals 2 bracket 4.
Minus 5.
Yeah, and what's 2 times 4?
8. So it'll be y equals 8 minus 4.
8 minus 5.
Or minus 5.
And that's what?
3.
3. Okay? I did a deep knee bend there to write down at the bottom of the board there. That's pretty impressive. I didn't know you still had it in you. 50 years old. All right. Okay. If this was Canada's Wonderland, we just went on the Dragonfire. Did anyone go to Canada's Wonderland this year? They still got the Dragonfire? The dragon out front, and they still got that ride? Okay. Not bad. Not a bad ride. Okay? We're jumping right from that to the Leviathan here now. Things are about to get nuts. Okay? Are you ready? Seatbelt on. Stay for one more. Stay for one more. Do you need more time here?
Yeah.
Yeah, more time? Good. I'm so happy you're copying it down. Good job, Adam. See, I mentioned your name. That way, if you want someone to watch the video, hey, watch this. He mentions me in the video. I was doing a good job. I love your sweater, too. I'll mention that, too, on the video. Yes, he's like, thank you. That's good. That's really going to help me when I get home. Thank you. Why is copying down the notes so important? It helps you know it. But there's something more. Why else is having the notes so important? Yeah, so you can look back at it when you're trying to do the homework. But now you got the videos too, right? Yeah, you're having trouble with the homework question night? Go back, watch the video, and go, what did he say about that? Geez, I was having trouble paying attention. I fell asleep. I was playing with my phone. Whatever it is. You can look back, check it out. At 1.5 times speed, you can make me sound like Alvin and the Chipmunks. Maybe at some point I'll speak like Alvin and the Chipmunks. Then you can speed it up at home, and then it'll be crazy. Are you ready? Look, I killed some time. I gave your brain a little bit of time to rest. Mr. Todd says, that's not fair. That's an easy one. He then posed the following question. Y equals 2x plus 3, and y equals x plus 4. And here's what I'm going to do. Some crazy substitution. I'm going to use substitution on this. Substitution. I'm going to say, okay, listen to this sentence. If I land this sentence, if I say it and you get it, it's going to go from hard to easy all in one sentence. Watch what I underline. Get your pencil ready to underline at the same time. If I say it just right, if your brain receives it just right, our problems are over. Ready? Here comes the sentence. If y equals 2x plus 3 and y equals x plus 4, then 2x plus 3 has to be equal to x plus 4. I just looked and went, well, those are both y, so they have to be the same thing. If I'm going to do the point of intersection, those two equations have to be the same thing. They have to give the same value. That's not the only way to look at it, though. If that slipped by, you're like, I don't know if I get that. All I did is I said, okay, in this second equation, y equals x plus 4, what I did was I substituted in 2x plus 3 into that y. I said, oh, that 2x plus 3 goes right there. I'm going to sub it right in. And it becomes 2x plus 3 equals x plus 4. If you get that far on the question, you can then go on the app, the Pizza Hut app, and order a pizza for dinner because you'll be like, I got it, I'm home free. Yeah? That's pizza time. Hold on. Don't get away. Don't get away on me. Yeah? There's a little bit to talk about here. And it's a part we've had a little bit of trouble with, actually. If we want to solve for x, we've got to get x onto one side of the equation. Yeah? It's on both sides right now, and we got to get numbers to the right. We did talk about this, but sometimes in math, it takes the second time through before you go, oh, I get that now. So here it comes. You didn't have to copy this, did you? 2x plus 3 equals x plus 4. Solve the equation. The plus 3, I want to move over to the other side. What happens to it when it moves over? It becomes negative. So the first thing I'm going to do is go x plus 4, and I move the 3 over, and it becomes subtract 3. The opposite of adding 3 is subtract 3. And then I'm going to tidy things up a little bit. Yeah, that's exactly what's coming next. First, I'm going to tidy this up, though. What is 4 minus 3? 1. Now, I want x's on the left. When I bring this positive x over to the left-hand side, what does it become? Negative 1x. Or you could just write negative x. Either way is fine. And what's 2x minus 1x? 1x, or just x. Oh, come on. Take a second and draw a smiley face there. Maybe you'll put Mr. Todd's haircut on there, will you? It's not bad, eh? It's pretty close. My brother used to make fun of me. He says, you always have a Lego guy haircut. You look like a Lego guy.
Do we have permission to laugh?
Yeah. It's all right. I heard that line for 20 years. It's not going to bother me now. Yeah. I got the x. X equals 1. Better than graphing? I don't know. Now, he's all over it. He went back and said, now I can just put it back in here. Now I'm where I was before. I've got the x. So I'm going to write a sentence to help you, okay? Sub x equals 1 into y equals 2x plus 3. He chose the first equation. In a second, I'm rigging you up to ask a great question on the video. The great question is, could I use the second equation instead? That's your great question. Get ready if you want to be the one to ask a great question. So here's Joseph doing it. He goes, y equals 2 times 1 plus 3, y equals 2 plus 3, y equals 5. We did that earlier in the lesson, so I'm just doing that a little bit faster, not because I'm rushing you, but because I'm going, oh, we were doing some of those. We were subbing those in. Who's ready to ask the really great question on the video? Joseph used y equals 2x plus 3. That's what one he liked. Could he have used y equals x plus 4? Oh, we better check, eh? Sub x equals 1 into the other equation. And watch what happens here. What's 1 plus 4? Also 5. Both equations will give the same answer. So it doesn't matter which one you sub back in. Final answer. An x and a y. What's the x? 1. What's the y? 5. Mr. Todd, I think that would have worked with graphing. I'm like, I know. These ones would work with graphing. But I'm setting up to do one. I think I wrote that in the wrong spot, though. If you look on your sheet, there's a spot to fill it in. Oh, it's not on my sheet. Or do I got to scroll down for it? Do you have it? Do you have it on yours? Way down where? It's got, oh, there it is. It's like exactly 6 centimeters lower. The point of intersection is 1, 5. Ms. Todd, it's a lot of steps, man. Please tell me you got something better to do the steps. I do. There's a recipe right there. Recipe says, make sure at least one of the equations is y equals or x equals. Substitute it in. Solve what you've created, and then substitute it in again. Scout, yes. Will, please. Yes, glad, 2. If you can wait, because I got 2 to do, where we use the recipe, and then I'm done, and then you got to practice. Then I'm going to do a homework check. So I know, it's been forever. When you're so young, you have to go to the bathroom all the time. Scout, are we good or no? She's good, she says. All right. All right, I don't know. I don't know how well I did. Very scary. These questions are very scary because if you don't know the first step, you can't do anything. Y equals 3x minus 10, y equals x minus 2. Let me try my sentence again. If y equals 3x minus 10 and y equals x minus 2, what could I write algebraically about this situation?
3x minus 10 equals x.
Yeah, you're saying the same things. You just go bang. I don't know which way around you say it, and it doesn't matter which way around you write it. 3x minus 10 equals x minus 2. It's pizza time. You get that line, things are going to be good. If they're both y equals, just set them equal to each other. They're both y equals. Let me say that again. If they're both y equals, just set them equal to each other. Now, these steps we've been hammering away on all semester. So let's go over them again. I want to move this negative 10 over to the other side. What does it become when I move it over? What's the, oops, that's just a miswriting there. That is not, I'm not doing anything funny there. I just wrote the wrong thing. What's the opposite of subtracting 10? Adding 10. And then a little collecting. Negative 2 plus 10. Please don't rely on mental math anymore. You can do the mental math and see, what do I know what negative 2 plus 10 is, but get the calculator out and make sure. Negative 2 plus 10, what do you get? Positive 8. Good job, both of you. Both of you, good job. Next, I want this x from the right-hand side of the equal sign. I want it back over on the left side. When it comes over, it was positive x on the right side. Now that's on the left side of the equal sign. What kind of x is it? Negative x. And what's 3x minus x? 2x. This one has an extra step. The opposite of multiplying by 2. Divide by 2. And 8 divided by 2 is 4. That gets the big smiley face. Come on. That is awesome algebra. That's heavy stuff. Look at all this crazy algebra on the board.
Oh my gosh, I missed like a.
This is getting close to that. It's moving our way towards that. What? What happened?
I was sharpening a pencil and then that happened and I missed it.
You just copy it down? No, just copy it down. No. Because I'm not done. In the words of the Cat in the Hat, that is not all. Oh no, that is not all. I got more to do. Who's got this? Who's got this? What don't I have? I've got the x value now. What's the other thing I need? The y value, yeah, so I got to put that in. So here's my fancy sentence. Substitution x equals 4 into, which one should I put it in, or does it matter? It doesn't matter. Both will give the same answer. So which one looks easier? Which one's going to be easier to sub into? Which one has less calculations? The second one. Yeah, so you could use the first one, but why not use the second one? So y equals x minus 2. So I'm subbing in 4. And what's 4 minus 2? 2. Answer. I don't know why I wrote an M there. Answer. What's the answer? What's the x value? 4. Y value 2. No graphing. Can we do one more? Yeah, I got one more for you to do. It's a little bit of trouble, this one, let me tell you. It's a little bit of trouble. Do you need more time? Okay, if your brain is fried, it's the last one. But I need someone super clever to help us with the first line of the next one. Because I made it slightly harder. Let me rewind the video for a second. I'm going to try and rewind the video. Are you ready? For the big moment of the lesson. It was a few minutes ago. Here's me rewinding the video. Right here. If they're both y equals, you just set them equal to each other. And at that moment, it's like, well, what if they're not y equals? Okay, let's fast forward back to where we were in the video. Are these both y equals? No. One of them is. Small smiley face here. It's like, okay, that one's y equals. But this one's not y equals. I like using an arrow here. You can do what you want, but I like using an arrow going, wait a minute. I can fix this. Just move it over. What has to move over? The 3x. And when it moves over, what happens? It becomes negative 3x. Not too bad. Not too bad. And now I can use my line from earlier. As long as they're both y equals, set them equal to each other. Who wants to set them equal to each other? Here it is. What's the first y equals? What's the second y equals? Okay, that's smiley face time. Bonus marks in the test for putting a smiley face after that line, where I go, yes, I'm okay.
10 extra marks for the smiley.
10 extra marks. I'll make the test out of 1,000.
Yeah.
Okay, if you're having trouble with this algebra, here's me helping with the algebra a little bit. Yeah? Here's me helping a little bit. That's got to move. We can't have numbers on the left side of the equation. That's not what we want. Numbers got to go. And so, when I move that over, it's subtract 4 over here. What does it become when I move it over to the right side? What's the opposite of subtracting 4? Adding 4. Yeah, good. And then I tidied up a little bit. 1 and 4 is 5. Next, me helping with the algebra a little bit. If you have trouble with these steps, I'll underline that and go, wait a minute. We're not supposed to have x's on the right side of these equations. So when I bring that negative 3x over, what happens to it? It was negative 3x over there. When I bring it over, positive 3x. Hopefully that's getting a little repetitive. Hopefully it's like I'm starting to, just by pure, you've done it 1,000 times, Mr. Todd. I'm getting this algebra because it's just repetitive. That's the plan, yes. 2x and 3x? And the, oops, got ahead of myself there. What's the opposite of multiplying by 5? Divide by 5, so I go 5 divided by 5, which is 1. But that is not all. Oh no, that is not all. I've got the x value, 1. I can put it in there. Now I need to get the y value. Sub it in. So, do the fancy sentence till you're getting really good at it. Sub x equals 1. Into, it doesn't matter which one, I'm going to choose 2x minus 4. And I did those steps fairly quickly, not because I'm rushing the lesson, but because I'm like, okay, it's part of the procedure, understand the procedure. Then sub it into the other equation to get the y value. Do you have any questions? Yeah. Watch this move. What day of the week is this? What day of the week is this? Thursday. Do you need more time here before I do my big move of the day?
Yes.
Need more time? Yeah. I'm just going to write one more word. One more word. I got to get in. One more word. More time here? Who needs more time here? I'm not rushing you. I'm not. I'm also just trying not to bore you. Too late, Mr. Todd. Big moment coming. Good? Anybody else? More time? Whoa. Substitution, practice questions. How many questions do you have there in your practice homework? 6 questions. Ready? One more word in this lesson. How does that change our thinking? It's with marks now. Yeah? So if homework you do 50% effort, which I hope your effort's higher than that, but if it's not, if homework you do 50% effort, assignment is like 85% effort. I've just left a little space there.
I thought that. Christian. I know they went there.
Those 6 questions can be handed in for marks. Why do I do stuff like that? Let's, just in case you want to be a teacher someday, what am I up to? I'm up to 3 different things at the same time. 1, I think it's important. 2, I'm willing to pay marks for you to get this, because if you understand this, you'll do great on the test. But there's a 3rd thing. Tomorrow's lesson, if you don't understand this, you might have trouble with tomorrow's lesson. 6 questions, see what you can do for tomorrow, okay? Come and see me if you have any problems. Or call me over. I'll be glad to come over.